Let's take a look at the process of multiplying polynomials. If we're given a pair of monomials, where each polynomial just has a single term, we can gather together the similar factors. 4 and -6 are constant factors. There's an x factor in both monomials, so I could write that as x times x to the fifth, and y to the third times y squared. Because everything here is just all of this is just multiplied together, and the order of multiplication doesn't matter. I can rearrange the order in which I multiply things. So I can multiply the 4 and the -6 together. That'll give me -24. I can multiply x times x to the fifth, and to do that I can think of adding their exponents. When there's not an exponent explicitly written, the default exponent is 1, so this is like 1x times 5 x's multiplied together, so we get x raised to the 6th power, 1 plus 5, and then finally y raised to the 5th power, 3 plus 2. Things get a little more complicated when the polynomials have more than one term. So I'm going to start with a simple example of just a constant polynomial. The number 4, I could think of that as a degree 0 polynomial. And then we have a binomial with two terms, 2x plus 10. So I wanted to start with this simple example and illustrate that multiplication is a way to describe repeated addition. So 4 times this 2x plus 10, another way to think of that, it's like I want to take 2x plus 10 and add it with itself 4 times. Now this is not something that we're going to want to do for every problem, but just to illustrate why we get the answer that we do. So 4 times 2x plus 10, it's 2x plus 10 plus 2x plus 10 plus 2x plus 10 plus 2x plus 10. But similar to what we just did with multiplication, I can rearrange the order of addition. So I really have 2x added to itself 4 times, and 10 added to itself 4 times. And so, gathering together the 2x's, that's going to become 2 plus 2 plus 2 plus 2 is going to be 8x. And gathering together the 10's, we get 40. 10 plus 10 plus 10 plus 10. Of course, the shortcut way to get from here to there is to multiply the 4 times 2x. 4 times 2 is 8, and 4 times 10. 4 times 10 is 40. In words, the process here, it's called distributing. We can distribute 4 in this situation as a factor because it's multiplied with the other part of the expression. We can distribute factors across addition. And I should say we can distribute them across addition and subtraction. So we can distribute factors to the different terms of an expression. So with a more complicated example, we can tackle it in a similar way. If I have 5x squared, now I don't have a definite number of repeated addition, but in a similar way I want to repeatedly add this expression to itself. So that means that I want to repeatedly add 3x to itself this many times, and similarly 5y squared and -8x squared times y. So we can simply do the distributive part, and I can multiply 5x squared times 3x times each of those terms. 5x squared times 5y squared, and -5x squared times 8x squared y. And so now each of these becomes like a pair of monomials multiplied together. So we can multiply the coefficients and add the exponents in an appropriate way. So we get 15x cubed plus 25. Now there's no common variable here, so we just get 25x squared y squared. And finally minus 40, 5 times 8, x to the fourth power times y. I encourage you to pause the video for a moment and try to multiply the following pair of polynomials: 3a times b squared and 10a squared plus 5ab cubed minus 2b. In a moment or two, I'll write down the answer to this. So I encourage you to pause the video and try to answer the question on your own first. Alright, I hope you were able to take a few minutes and come up with an answer to this. Let's take a look at what we can get. So multiplying 3ab with each of those terms, we end up with 30 a cubed times b squared plus 15 a squared times b to the fifth power and negative 6 a times b to the third power. I hope you enjoyed the video. Thanks for watching.